Today we will be learning how to apply the product, quotient, and chain rule to tables and graphs. These rules are vital in calculus in order to correctly compute the derivatives of two or more differentiable functions. First, we have the product rule, which is used to find the derivative of the product of two or more differentiable functions. In this rule, you take the first function and multiply it by the derivative of the second function, and you add that to the second function multiplied by the derivative of the first function. Next, we have the quotient rule, which is used to find the derivative of the quotient of two or more differentiable functions. In this rule, you multiply the function in the denominator by the derivative of the numerator and subtract that by the function in the numerator multiplied by the derivative of the denominator, and you divide all that by the function in the denominator squared. Or you can look at it as high over low equals low d high minus high d low over low low. Next, we have the chain rule, which is used to find the derivative of the composition of two or more differentiable functions. In this rule, you take the derivative of the outside while keeping the inside function unchanged, and you multiply that by the derivative of the inside function. Each of these rules can be used singularly or combined in order to find the derivative of the functions and solve for specific values of x through tables and graphs. In tables, the values are given, and in graphs, the lines are plotted. So first we're going to look at table problems, and this first example here utilizes the product rule. So the function given is p of x equals 4f of x times g of x, and the first thing we're going to do is write out the first function, which is 4f of x, and find its derivative, which is just 4f prime of x, and then we're going to write out the second function, which is g of x, and find its derivative, which is g prime of x, and then we're going to utilize the product rule. So that's going to be p prime of x is equal to the first function times the derivative of the second function plus the derivative of the first function times the second function. And the problem is asking for p prime of 5, so we're just going to substitute 5 in for all the x values as shown, plus 4f prime of 5 times g of 5. And then we're just going to look at the table where it says x equals 5 and correlate those values to the problem, and that's just going to be 4 times 2 times 1 plus 4 times 3 times 1/3, and that is going to give us p prime of 5 is equal to 8 plus 4, which is just going to be 12. And that's it for the first example. As you can see, all you have to do is use the product rule and correlate it to the values on the table. So for the second example here, we're going to be utilizing the quotient rule, and the function given is k of x equals f of x over g of x, and we're going to do the same thing as the problem above. Write out the first function and find its derivative, which is f prime of x, and then write out the second function, which is g of x, and find its derivative, which is just g prime of x. And then we are going to utilize the quotient rule, which is just going to be the function in the denominator times the derivative of the function in the numerator minus the function in the numerator times the derivative of the function in the denominator all over the function in the denominator squared. And the problem is asking for k prime of 3, so we're just going to substitute 3 in for all of the x values, so minus f of 3 times g prime of 3 over g of 3 squared. And then we are going to go look back up at the table and look where it says x equals 3 and correlate those values again to the problem, and that is going to give us negative 1 times negative 10 minus 4 times 1 all over negative 1 squared, and that is going to give us k prime of 3 equals 10 minus 4 over 1, and k prime of 3 is going to equal 6. And that's it for the second example, which just utilized the quotient rule. Now, this third example of a table problem utilizes both the product rule and the chain rule as shown. So the function is h of x is equal to f of x times g of f of x. And so we're going to do the same thing. We're going to write out the first function, which is f of x, and find the derivative, which is f prime of x. And then for the second part, we're going to be utilizing the chain rule in order to find the derivative. So we are going to write out the first function, which is g of f of x, and then the inner function is going to be f of x, and then find the derivative of both, which is going to give us g prime f of x times f prime of x, and that is going to be the derivative of our second function. And so now we're going to apply the product rule. So that is the first function, which is f of x, multiplied by the derivative of the second function, which is g prime of f of x times f prime of x, and then add that to the derivative of the first function, f prime of x, times the second function, g of f of x. And then it's asking for h prime of 1, so we're just going to plug in 1 for all of the x values as shown. So f of 1 times f prime of 1 plus f prime of 1 times g of f of 1. And then we're going to look at the table of values above and plug in all the numbers. So that's going to be 2 times g prime of 2, because it's a composition of a function, so that means that you still have to find g prime of 2 and g of 2, and then look back at the table for those values, which is 2 times negative 8 times 4 plus 4 times negative 2, and that is going to equal negative 64 minus 8, which will be negative 72. So in this problem, you can see how both product and chain rule were utilized. So in this example, we are going to be looking at a graph to find our values, and the function given is m of x equals 2h of x plus x divided by j of x minus 1. So we are going to be utilizing the quotient rule, and we are going to write out the first function, which is 2h of x plus x, and find the derivative, which will be 2h prime of x plus 1, and then do the same thing with the second function, j of x minus 1, and find the derivative, which is just j prime of x. And then we're going to apply the quotient rule, which is the bottom times the derivative of the top minus the top function times the derivative of the bottom, all divided by the bottom function squared, as you can see here, minus 2h of x plus x times j prime of x, and this is all going to be divided by j of x minus 1 squared. And the function asks for m prime of 1, so we are just going to be plugging in 1 for each of the x values, so j of 1 minus 1 times 2h prime of 1 plus 1 minus 2h of 1 plus 1 times j prime of 1, and that divided by j of 1 minus 1 squared. And now, in order to find the values, we're just going to be looking at the graph. So to find the values on the graph of just j of 1 and h of 1, we're going to see what they equal at x equals 1 at the lines plotted. And to find the derivative of j of x and h of x, we're just going to calculate the slope at x equals 1 in order to get those values. So over here we have 2 minus 1 times 2 times negative 3 plus 1 minus 2 times 3 plus 1 times 2 all over 2 minus 1 squared, which is going to give us 1 times negative 5 minus 2 times 7 over 1 squared, which is just negative 5 minus 14 over 1, which equals negative 19. In this problem, we used the quotient rule and found the values through a graph. So this is another example using a graph. And as you can see here, we are going to be applying the chain rule multiple times, and the function given is w of x equals p of q of 3x minus 1. So the outermost function is p of q of 3x minus 1. Then the inside function is q of 3x minus 1, and the innermost function is 3x minus 1. So in order to apply the chain rule and find the derivative of this, we have to take the derivative of each of those functions. So the derivative of the first function is p prime of q of 3x minus 1. The derivative of the second function is q prime of 3x minus 1, and the derivative of the third function is just 3. And it's asking us to find w prime of 1, so we're just going to plug in 1 for all of the x values here, and that is going to give us p prime of q of 2 times q prime of 2 times 3. And we're going to be looking at the graph here to find where q equals 2 and find where q prime equals 2 as well by looking at the slope of the graph. And that is going to get us p prime of 1 times -1 times 3. And now we're going to look at the graph to see what the slope of p is at a value of 1. So once we calculate that out, we are going to get a value of -2 times -1 times 3, which is going to give us -2 times 3, which equals -6. So in this problem, we applied the repeated use of the chain rule in order to solve. In this last example here, we will be utilizing both a table and a graph to solve the function, which is m of x equals f of g of x divided by 2h of x. In this problem, we will be using both the chain rule and the quotient rule in order to solve. So first, we're going to write out the first function, which is f of g of x, and here we're going to apply the chain rule in order to find the derivative. So the outermost function is f of g of x, and the inner function is g of x, and we're going to find the derivative of both, which is going to give us f prime g of x times g prime of x. The second function is 2h of x, and the derivative of that is just going to be 2h prime of x. And now we're going to apply the quotient rule, which is just the bottom function, which is 2h of x times the derivative of the top function, which is f prime of g of x times g prime of x, minus the top function, which is f of g of x times the derivative of the bottom function, which is 2h prime of x, all divided by the bottom function 2h of x squared. And the problem is asking to find m prime of 8, so now we're just going to plug in 8 for all of the x values. And over here we're just writing out g prime of 8 minus f of g of 8 times 2h prime of 8 all over 2h of 8 squared. And now we are going to look at both the table and the graph for values. So over here we are going to be using the table for h and h prime values, and for f and g values and their derivatives we're going to be looking at the graph. Remember, to find the derivatives of values on the graph we have to calculate the slope at that point. So over here we have 2 times 2 times f prime of 2 times -1/2 minus f of 2 times 2 times 1 all over 2 times 2 squared, which is going to give us 4 times 1 times -1/2 minus 7 times 2 over 16, and that is going to give us -2 minus 14 over 16, which will give us -1. So in this problem, we utilize both the table and the graph in order to solve m prime of 8. That's it for all the example problems. All the problems and tables were created by me, but they were inspired by calcworkshop.com and the Black River Math Circuit by Vicky Carter. The first graph was from there as well, and the second graph was from activecalculus.org, and the third was from mathfortress.com. Hope you learned a lot through this video. Bye!